Okay, this is the Lab 3 Part 2 help video. Okay, we've seen this before, that we need to learn how to make a symbol, make a full adder, 4-bit cascade adder, do BCD addition and subtraction, array variables, test bench for array variables. Okay, so we have to make a full adder component. Once we have a full adder component, actually we can make this full adder component from a schematic, right? So what's schematic? What's schematic? From this schematic. So we could draw this schematic in coordinates and save it as fa.bdf. And we can convert this into a symbol, and this becomes a symbol, a full adder symbol in our 4-bit adder. That's how this works. So first, we have to create the full adder symbol. Then we have another schematic. Okay, and we put 4 of these full adders, hook them up, and then we turn that schematic into a symbol. Okay, and then we have how many schematics? We're going to have even one more schematic. You're going to have this schematic, your final schematic. So there's going to be 3 schematics. And now, you ever heard about me talking about top level entity? That's where this comes in. So the final schematic is a top level entity. When you go to making your test bench, you need to be sure that you've correctly established top level entity, because it doesn't know whether to make a test bench for this top level entity, or make a test bench for this 4-bit adder, or make a test bench for the full adder. It doesn't know unless you specify top level entity. Now, if you don't specify top level entity by right clicking on the file, set the top level entity, it assumes that top level entity is the same name as the project name. Yeah, okay. So instead of having to draw all those gates for the full adder, you can make yourself a VHDL template. You don't have to draw the full schematic. You can draw input-output markers, X, Y, C, N. These are inputs. Okay, you have to establish in your mind what are the inputs and outputs of the full adder. Well, it's X, Y, C, N, and the outputs are sum and carry out. So you just make a schematic with these pins alone, and then go file, create, update, turn it into a VHDL code. And then you'll get this VHDL code, which is a template. And it doesn't show the begin and end, but you'll be able to write your equations between the begin and end. The equations relate the C out and the C in. Sorry, the outputs. You have only equations for the outputs. So you have equation for the sum output in terms of X, Y, and Cn. Equation for the C out output in terms of X, Y, Cn. And that saves you a lot of drawing. Now you're going to get a ton of warnings because of this, because you don't have any circuitry drawn. Okay, now, once you've got your full adder component, you can put them on a screen. I've shown 2 of them on here. You're going to need 4 of them. Okay, so you need 4 of these components, and then you make an adder 4, and then you turn the adder 4 into a symbol, and you need 2 of those symbols on this schematic. You need to hook them up like this. Now, at the top level here, we're using vectors. Okay, so instead of saying A3, A2, A1, A0, you say A square brackets 3, period, period, 0, right square bracket. Okay, so that'll give you a vector. So we'll see the advantage of vectors when we get to the test bench. Also, we can use bus operations. We can invert an entire vector this way. You see the B3 dot dot 0? That entire vector can be XORed with M to get a ZB vector, which connect with the ZB3 through 0, connect up to ZB3 element, ZB2 element, ZB1 element, ZB0 element. So this ZB with square brackets and a single number represents an element in an array. And this b square brackets 3 dot dot 0, that's an example of an entire array. Okay, so I have a bus document. Explains how to use a bus. Okay, so I can OR these two buses together. See, I can OR the Y30 with the V30 to get the W30, and it got cut off somehow. Okay, and on our pins we have vectors V30, X30, and so forth. Now, to draw buses, we use this bus tool. That's the thicker one. We don't use a regular wiring tool. So that's for buses. So, now when we have buses, our test bench can change. We could assign the vector elements individually, like it's done at the top here in green. So this is commented out because we're not going to do it this way, but you could do it this way, assign each vector element. So this test bench is VHDL. VHDL elements are in round brackets. And less than or equal to means assignment. And 0 in single quotes is the 0 constant. 1 in single quotes is the 1 constant. So we could assign the vector elements individually, or we can do vector assignments, which is the preferred method, which we'll do. Okay, so M is 0. So the A is assigned 0, the B is assigned 0. Wait for 10 nanoseconds. So that's one of your first examples, 0 plus 0. And then you assign 5 plus 4. So a 4-bit constant in double quotes, that's a vector constant. So that assigns to A3, A2, A1, A0 all at once. So doing it this way gives you a nicer test bench. You can see that here the A is this 4-bit value. It's a vector, and B is a 4-bit value of vector. 0 plus 0 plus is 0. 5 plus 4 is 9. 7 plus 5 is, well, you get a 2, and then overflow slow 12, and so forth. Now, this actually repeated itself. Or you can do the last one. 8 and 8 is 16, which is 16 overflow, and then it repeated itself somehow. I should have limited the simulation time. Okay, but that shows you the advantage of using vectors. So there's a lot learned in this lab. Okay. So this is going to be very, very complicated. Okay, here we go. So we'll start doing the lab. I'll help you here. Otherwise, you don't know how you're going to do it. So we've opened up Quartus, and we opened up the Lab3 Part 2 project. Now, before you continue, you must look at the very top line after the blue globe. It says Quartus Prime Light Edition, C Intel BG Light, 18.1, Lab3Pt2, Lab3Pt2, Lab3Pt2. Okay, so if it's not putting you in that folder with this project name, it's in some kind of other place like C app data, which is a hidden file where browser files get downloaded. If it ended up there, it means you unzipped correctly and you need to start over. But I have it right. So you're going to change hierarchy view to files view. Then, since you're new at this, you probably don't know what to do next. So you could, where's my document? Thought I had it open. Yeah, you go to simulation step summary. So you need to do file new to create a blank schematic file and save it as, in your case, lab3 part 2.bdf. Okay? And then this will tell you step by step what to do. Once you've done this already, you only need summary steps. Okay, so, okay, but that's what we do the ordinary way. But now we're going to use a symbol. So we need to do our symbols first. Now, this thing has a problem that it doesn't like you to create symbols when the top level entity isn't in existence yet. That can cause a problem. So to overcome that problem, you would have to temporarily right-click on the FA full ladder to make it top level entity until you finish it, and then then you change top level entity to the Lab3Pt2.pdf. So that's a quirkiness of this software. All right, so what we're going to try to do is so we're going to try to get a new schematic. Okay, we want this to be a full adder. So we're going to do save as, actually FA. FA, the full adder. We got to make the full adder first. And we don't want to add it to the project. Okay, so there's a full adder. Now, like I said, we could go, draw all this in a schematic and then turn it into VHDL code. Okay, and what does the VHDL code look like? Well, we saw the template in the other slides. All right, so to save time, we are just going to put an input-output marker. Input and output marker, I mean. Okay, so what are the inputs? Well, what if you can't remember? Well, you got slides. So they're called X, Y, C in, and sum and C out. Okay, so now you're learning you can have more than one variable name on an input marker or output marker. But they got to be separated by commas. And there has to be a space after the comma. Students think, well, the space after the comma can't make any difference. Okay, it can. It can make enough difference that you have to start over. So put the space after the comma. Every time I teach this, students say, think, no, he can't be right. The space after the comma can't make any difference. Okay, sometimes it does, sometimes it doesn't. The times that it causes a problem, you have to start over. So put the space after the comma. So we want to get this template. All right, so what did it say? Oh, forget it, I can remember. X, comma, and then capital, Y, comma, space, and then C, capital C and IN. And then this is going to be SUMCOUT. Sum and carry out. What do they have in the slides? No, not those slides. Yeah, sum and carry out. Okay. I don't know if the order of these two is going to make any difference, sum and carry out. I put sum first. All right, so I got a schematic, and I save it. Okay, and it's using the name fa.bdf. Now what I'm going to do is generate VHDL code. Okay, because I don't want to draw all those gates. I don't want to draw the exclusive OR and the AND OR structure. I don't want to do that. It's too much time. So I'm going to do file, create update. Create HDL from current file. Make a VHDL. Okay, 5 warnings, okay, because so many things are not connected because I didn't draw the circuitry, so that's fine. Now, where's my code? File open. fa.vhd. Okay, so it says entity FA. Where did it get the name from? From fa.bdf. So it says port. So it has an input called X, an input called Y, an input called CN, an output called sum, and an output called Cout. So now you need equations that relate the outputs to the inputs. For everything that's an output, you need an equation. So the equations go between begin and end. So you have equation sum, SUM. I will pay attention to case sensitivity. VHDL does not know the difference between uppercase and lowercase, but Verilog does. So sum is, now what's my equation? What if I couldn't remember? I got here. X exclusive or Y exclusive or Cn. It's going to be X XOR Y XOR. The XOR can be uppercase or lowercase. And it has to end with semicolon. So the sum equation is X XOR Y XOR Cn. So we just learned that in VHDL less than or equal to its assignment, and XOR, either uppercase or lowercase, is the exclusive OR operation. Now, C out, it's got to be typed exactly the same way. I'm going to copy and paste it over to make sure. Less than or equal to. So I have X and Y. The and could have been uppercase. Now, VHDL doesn't know about operator precedence. So you have to put brackets around AND expressions. Now, OR is OR. Or X and Cn. Or Y. Oh, I forgot about brackets. Y and Cn. Okay, and save it. Save it. Now, is that right? What did it say? X, Y, XCN, YCN. Yeah, I got it. Okay, now, you need to turn this into a symbol. Well, what if you don't know how to turn things into a symbol? Well, there's a document here that tells you how. Okay? It might take you a long time to get through it. I don't know. And the document gives you the shortcut method of going directly to VHDL code with a template, like we're doing. All right, so you don't have to read the document. I'll tell you what to do. So to make a full adder symbol, I need either a full VHDL a full adder schematic. I need a complete schematic, or I can use the full adder VHDL code I generated from the partial schematic, one or the other. And I turn that into a symbol. How? File, create update. Create symbol file for current file. I'm going to leave it there for a moment so you know what the menu it is. Create symbol file for current file. Zero errors, zero warnings. Okay, this is part of my project, so I got to use project, add current file to project. I got to put that in a project. Now, I haven't come across a top-level entity problem so far. If it would have balked about top-level entity, I would have had to temporarily make this top-level entity until I got it done. Then later on, when I get to my final schematic and get the VHDL code for that, then make that the top-level schematic, top-level entity. Okay, now what? All right, I need to make a 4-bit adder. So new block diagram schematic file. Now I need a name for it. I don't want to call it block 2. So save as. ADDR4. I don't want BDFs in the project, so uncheck that. If that got accidentally added, I would go right-click and remove it. Okay, so now I can remove this catalog area, the upper X. And I can start drawing my schematic. Now, watch what's going to happen when I go in my symbol tool. So it says libraries project. Under project, there's FA. Where'd that come from? We put it in a library. When we made our symbol, it became part of the library like all the other things. Like and or not and all this. So you pick your full letter. You plunk it down. Now, notice inputs on the left, outputs on the right. We want it the other way around. So there is here, flip horizontal. Do you see it? In the tools menu. Flip horizontal. I flipped it. So now I can work right to left. So it'll come out looking like this. I want to draw this. Draw this. Draw this. I'm going to draw this. Okay. So I need some more of these. Control C, right click paste. Right click paste. Right click paste. Okay, so some showed up at the top, which is good. Right now, save that. Now, what are the pin markers? Okay, save that. Okay, what are we going to do now? We'll go look at the slide. Yeah, so you're going to have these. These are not vectors because I want a general purpose, simple to use component. I don't want a vectorized component. If you leave the spaces out, you're going to get a vectorized component with a bus that you won't know how to work with. So don't leave the space out. So I need the A's and the B's and the C in. So here we go. B3, B2, don't leave out the space. B1, B0. You got A3 through 0, B3 through 0, and what else? C in. Okay. Now what's the output? Not this. Yeah, so it's the S3 through 0 and C out. And what about the C out? C-O-U-T. So I got it. So here we go. So start wiring it up. Now, we're going to do boxcars. So get my wiring tool, not the bus tool yet, the wiring tool. C out goes to C in. They connect together like boxcars. Oh, there, I made a tumor. And save it. Okay, so how does this look? Zoom out. All right. So what I got to do now? Well, look at the slides. Not that. Yeah, so on the adder, we're going to use the names A's and B's. Okay? We got the C out to C and drawn already. We just got to put the A's and B's in. Okay? So each stage is going to have like A2, B2, S2, A3, B3, S3. In each stage, the subscripts are going to be the same. A common error made by students is to get subscripts out of step. So they might have, for example, A2, B1, S3. That won't work. They all have to be same subscripts on a given ladder. Oh, by the way, I need a ground on this CN. So go to the library, type GND. Stick it on there. Okay, it missed. Zoom in. Now use the arrow key. I got it. Now this final C out got to be what? C out. C out. Okay, now I'm going to have the X's or A's. Okay, don't put an O, put a 0. And the Y's are B's. So we got A0, B0, S0. Okay, and then it goes. Now, if you want, you can grab this and move it a little bit up if they're too crowded together. Okay, and if you can't see one, you can nudge it with the arrow key. You see, I nudged it. See if there's one. If it see here, I can't see it. If I can't see it, I can hit it and nudge it with the right arrow key. All right, so you got to complete the schematic. Now, I want to save time here, so I am going to do what? I got it drawn already. You don't. You have all this work to do. Okay. So it came out to what? A0, B0, O to CN. I made a mistake. You can't ground the CN. You know why? You can't ground the CN. It was a mistake. Why? Go here. When you get to the top level, the CN is your mode bit for add subtract. If you saw the previous lecture on video, the CN gets the mode bit, so you can't ground it. So, go back to what we had. You got to remove the ground. You can't have a ground on there. And call it CN. Call it CN. Okay, that's a mistake you likely would have made. So it's a good thing it happened. It has to be CN because there's got to be a general purpose component that can be used at a higher level. Okay, you see that correction? Do not do that. Put a ground there. Okay, so I got it done already. Okay, so with very little work, it's got it done already. My schematic is complete. So you see here, I don't have the ground on CN. CN is an input at this level. Now, what I need this for is it has to be a component on my overall schematic. This is my overall schematic. It needs two adder 4s, two 4-bit adders. So I need to turn this adder 4 into a into VHDL code and into a I have to turn it into a VHDL code, and then I turn the VHDL code into a symbol. Okay. So file, create update. When I create the VHDL code, I will know if I got any errors. And I didn't. Now, what bothers me is a Lab3 entity, double quotes, with nothing inside for the top level entity. So it does not know what the top level entity is right now. Actually, it does, because the top level entity has the same name as the project name, but it's not using a top level entity. All right. Find that code. Adder4.vhd. This adder4 one you don't have. That is the saved work I had, so I could go faster. So this is the VHDL code for the 4-bit adder. So entity adder4, it has the A bits, the B bits, the C in, the S bits for outputs, and a carryout. Okay, now this is what they call structural code. So it instantiates 1, 2, 3, 4 full adders and hooks them up. So it port maps them. So this full adder's X gets to A3, and its Y gets to B3. And the sum goes to the S3, and the C out goes to C out. Now, this is the stage 2. This full adder, its X gets A2, its Y gets B2, its C in gets synthesized wire 1. Okay. Where's synthesized wire 1? Right here. Yeah. So the C out of stage 1 is synthesized wire 1, which becomes the C in of stage 2. All right, now this one, synthesized wire 0, yeah. So the output stage 2, C out is synthesized wire 0, which becomes the C in of stage 3. So you're using these names to wire these full adders together. Now, yours probably got a different order. It's very likely yours is in a different order. So this makes sense to me. So I need to make a symbol out of this. So file, create update, create symbol file for current file. I'll leave it there for a moment so you can see it. No, not that. This. Stop signs up. Okay, no errors, no warnings. Now, what I got now? I probably got a symbol. So now I need to go to a higher level schematic. Now this schematic you need for your lab report. This is what you need for your lab report. You can zoom it out and do a window snip to put in your lab report. You need this for your lab report. Now this VHDL code you need for your lab report for the full adder. You need to show how you made your top level and your components. Oh, adder for BDF not supposed to be in the project list. So right click, remove it. But what has to be there? File open. Adder for VHD. That has to be in a project list. You need that. So we're gradually building up the VHDL files that we need for our simulation. Now, I need to do my top level. And what's it say? My top level is called Lab3Pt2Help. Actually, it's Lab 3 Part 2. Because this term, we have two parts. So I need a new schematic. File new schematic. And save it as Lab 3 Part 2. But don't add the PDF to the project. Okay, so Lab 3 Part 2 PDF. So we got to start drawing this stuff. So I got to go into my library. Go into project. Whoa, my adder 4 is there. And it's in the right orientation. I don't have to flip it. All right, let me do my input-output markers now. So at top level, I've got A vector, B vector, both 4-bit vectors, and M bit. And a sum vector and overflow. Right-click properties. Now watch. A, left bracket, 3, period, period, 2 periods, not any more or less, 3, 0. Right bracket, comma, space, B, left bracket, 3, period, 0, right bracket. Okay, well, we need a capital B. Okay, so this thing needs a mode control to decide if it's going to add or subtract. So space and capital M. Okay, as I told you, you could specify an individual element in one of these vectors with the name in square brackets. So verify that's happening here. The name in square brackets. Okay, so might as well get to work here. Okay, here we go. Okay, A. Use caps lock. A, square brackets 3. That's element 3. So A3 goes to A3. Now, I'm going to nudge that with arrow key. Or did I mess it up or not? Okay, now. A2 in square brackets. A1. Oh, sorry. A1. A0. Now these B inputs have to be conditionally inverted. Okay? So I'm going to use an exclusive OR with M to conditionally invert. And I'm going to use buses. Okay. Now, let's get my exclusive OR. XOR. So any standard component can be vectorized. Not the ones that you make as symbols, but the built-in standard components can be vectorized. Okay, so I'm going to take a bus. It says orthogonal bus tool. You see that? I'll leave it for a minute so you can see it. So the B bits will not go directly to the B inputs on the adder. They have a chance to be inverted first. B 3.0. So the entire B bit comes to here where it can be. Now I got to go to regular wiring tool. You see I did that? Right there. Orthogonal node tool. And then right click and M. Right click M. Okay, so the B vector comes in through this pin. It goes down here and it can get conditionally inverted with this exclusive OR. Now, okay, no, don't want that. I need a bus. Go back to the bus tool. I want to hook up this output to these Bs. Okay? So they need some kind of a temporary name. Okay? Some name that isn't one of these. So just any old name. So as long as they have the same name, they hook up. You know this, right? So call them Z. Z3.0. Okay, so these Z's got to hook up here. So we can specify elements like this. Uh-oh, wrong one. Go back to regular wiring tool. So watch. It's going to become Z square brackets 3. Okay, now I need more of these. Okay, so Z, I can cancel this. Hold on. Yeah, go back to arrow mode. Okay, so Z3, Z2. Z1. Yeah, Z3 goes to B3. Z2 goes to B2. Z1 goes to B1. Z0 goes to B0. And the C in gets the mode control. Okay, so the C in was left with a name, not with a ground on the lower level. So it's available to be assigned here. Okay, I got a lot done, so I'm going to do a save. And have a look at this. Yeah, so the A vector comes in, gets applied directly. The B vector comes in. It gets conditionally inverted. Conditionally inverted. And then the Z's here hook up to the Z's there. And now I've got my basic adder subtractor. Okay, so what I gotta do? I need another adder. I got it here in my library because I made it as a symbol. Okay, so put it on here. Okay, so what am I doing? Okay. This C out is going to be used. It's going to be used by the detector circuitry, which I didn't put in, and which you can find out from that document I was showing from the internet, when I did a BCD correction. So you have to draw those gates. Okay, so let me see. Okay. Yeah. So we're going to connect them together. Now, the question is, why are they named Z's? Well, those names are going to be needed with the gate network for the overflow. So the overflow comes in here. So the overflow does a couple things. Let me go full screen. The overflow does a couple things. One is it sets the two inner bits on the B side here to 1s when needed. Okay, so this B3 will be a ground. This B0 and this C and they're going to be ground. We're not using those. Okay, but we add 6 when needed by putting a 1 on overflow and setting the B2, B1 to 1. Okay, so that's that overflow circuitry. All right. So actually, I could leave this for you to figure out. But unless I go into the simulator, you're going to have big problems. So I have to get this done and go into a simulator because there's something totally new goes on in the simulator. The simulator has to know about everything in this list, this files list. All these got to get added to the simulator project. So I'll show you how that happens. Okay, meanwhile, this got to get saved. Save as. Lab3 Part 2. Don't add it to the project. Yeah, okay. So that's my Lab3 Part 2. Now, to save some time, I'm going to use an already drawn version. So where is this? Where I got it? Right there. Go back into here. Oh, where? Hold on. Yeah, okay, got it now. So open. Now you don't have, I got it done here, see? So, and then save it as. So this term we have 2 parts, so it's called Lab3Pt2. 3. Experiment 3 already. Don't add it to project, it's a BDF. Okay, so this is good. So it's fully done now, okay? So this is what you're going to need. All right, so this is when I got off that HTML document from the web. I just drew what it showed. Okay, so these got to be named Z's and C out. So these names are used in this network. You see this C out shows up here, and the Z's. So they got to be named on here. Otherwise, could have just drawn lines across. Okay, so to complete this, I gotta go get VHDL code for my top level. So for create update, HDL, VHDL, wait for a stop sign. Zero errors, 0 warnings. Now pay attention to errors and warnings. If there's error warning, you want to fix it. All right? You got to get this right. And there's no errors and warnings. Now, what I really want is that code. Okay, so file open. I really don't need the schematic except for the lab report to show that I did it. But for the simulation, I need the VHD version. So Lab3 Part 3 VHD. That I can add to the project. Hit that check mark. If it didn't get added to the project, add current file to project. But it's there. So these are all, okay, now watch. Immediately, Lab3 Part 3 VHD. Set as top level entity before making a test bench. Because when it goes to make a test bench, it'll make a test bench for the top level entity. I don't want a test bench for the full adder. A common mistake made by students. I don't want a test bench for the 4-bit adder. I want a test bench for the adder subtractor, Lab3 Part 3. So set that as top level entity. So make sure that it's going to work. Give the right test bench. Okay, so what it's doing is, it's got this top level entity named Lab3 Part 3, which became top level entity for sure after I did right click, set as top level entity. Okay, and it's got the M and A vector, the B vector, and the outputs, the overflow, and the sum. Okay, and then it has this adder for component, and it instantiates 2 of them and hooks them up. Okay, so that's good. There's a lot of things I don't need to look at. Okay, so at this point, I need to look at this code. So double click it. So this code got to be sent. I need a test bench for this code, not the other ones, this one. So this got to be synthesized. Okay, and because it's top level entity, it will synthesize this, the top level entity. So I go to this icon, this triangle on the right. There's 3 triangles. Take the rightmost one. Start analysis and synthesis. Whoa. So here we go. Look at the message window at the bottom. Stop sign still up. %4 done. You wait long enough, it'll get done. Okay, what's going on here? So now it's in the green comments here. It's telling you how it's compiling things. Okay, so it has to compile all of these lower level entities and the top level entities and put them all together somehow, and make a get information for making a test bench for the top level. So see it says elaborating entity Lab3Pt2Help for top level hierarchy. It knows that's top level now. It knows adder 4 and FA are somewhere in the hierarchy below it. So I came out to 0 errors, 0 warnings. Whoa, okay. Zero errors, 0 warnings. So it's now ready for a test bench template because we synthesized top level. So I'm going to go to processing. No, what if I didn't know what to do? What I would do? Simulation steps would somewhere tell me that I need to, after analysis and synthesis. Start processing, start test bench template writer, if I couldn't remember the command. Start menu. Start test bench template writer. I'll leave it there for a moment. Boom. Okay, that worked. Zero errors or warnings. Now, what did it say? Generated VHDL test bench file in this file path. So it's under subfolder simulation model sim with this name, .vht. And the netlist writer was successful. So we have some test bench code that I can find with file open. So under simulation, model sim is not there. Set the file filter to all files. That's it. Or you can add that to the project right there. There's this checkbox. Double click it. It's in the project now. You see? If it wouldn't be project, add current file to project. Now this is a test bench. How do you know it's a test bench? It says Lab3 Part 3 VHD test. So I know it's a test bench. Okay. So a common error is for students to take this Lab3Pt2Help design code and put their process lines in there instead of the test bench. So you have to put the process lines in the test bench, not the other one. Okay, so for your very last process always, you can erase this green comment and go to your slides. And see what it gives you for a test bench. What does it give you for a test bench? Yeah, this. So paste it in, Control V. All right. And save it. Okay, so now what am I going to do? You should have to figure out the next two cases. Okay? So what I can do is we're going to need 4 example problems. We're not going to do all 256 problems. Okay, see, there's 4 bits and 4 bits. There's 250. Oh, and there's even more because of adding and subtracting. Okay, so how many problems? So you got 4 and 4 is 8. 2 to the 9. Okay. So 528 possible problems, all right? Well, what's 2 to the 9? I haven't done that one for a long time. It's 256 twice. 512. I meant 512. So there's 512 possible different problems. We're just going to do 4. All right. Then we're going to edit these. So what are the kind of problems I can do? Well, don't have to be original here. You can go to the waveforms. So it did 0 plus 0, 5 plus 4, 7 plus 5. So it did 7 plus 5. Did 0 plus 0, 5 plus 4, 5 plus 4, and then it did 7 plus 5, and then it did 8 plus 8. Oh. Okay, this actually doesn't repeat itself. If this would be added, it would repeat itself. But it does all these problems as addition, and then it does them as subtractions. Now, let me see. Yeah, m goes 0, then m is 1. All All right, well, 0 minus 0 works because our subtractor will only allow us to subtract a smaller number from a bigger number. So when m goes to 1 to subtract, 0 minus 0 equals 0. 5 minus 4 is going to be 1. 7 minus 5 going to be 2. Oh yeah, it'll work. So these examples will work. Okay, so we got 0 plus 0, 5 plus 5, 7 plus 5, 8 plus 8, 1, 2, 3, 4. All right, let's go back to here. All right, so we got 0 plus 0, 5 plus 4. 5 plus 5 or 5 plus 4? Where is it? Come on. It is actually 5 plus 4. Okay, go back here. 5 plus 4. 7 plus 5. 8 plus 8. So this is 4 addition problems. 0 plus 0, 7 plus 5. So sorry, 5 plus 4, 7 plus 5, 8 plus 8. Now watch what I'm going to do. I need 4 subtraction problems. So Control C, Control V. So do the same thing over again with m equals 1. Now I hope you understand what these vector constants do. The entire vector A through A2, A1, A0 gets assigned this way, respectively, okay, for this second line. A3 gets assigned 0, A2 gets assigned 1, A1 gets assigned 0, A0 gets assigned 1. Okay, so I got the same 4 problems, m equals 0 for addition, and then m equals 1 for subtraction. And then save it. So now I'm ready to go for simulation. Okay. So what I got to do next? Well, maybe I can't remember. Simulation steps. Yeah, so I got the simulation settings next. Okay. So go assignments, settings for simulation. Okay, now the EDA Netlist Writer settings has already been done in a zip file. So there, that on is there. Yeah, it's for a functional simulation netlist. Then you need to compile a test bench. So you need to browse for it. Okay, so new, find it. Or you need to name it first. Part 2. Okay. Now use the browse icon to find it. Under simulation, under MOSM, Lab 3 Part 3 BHT is there. Now add it. Okay. Now hit OK. Well, yeah, it's got it there. So OK. Okay, it looks like it's set up. And then just do OK. So now we're ready to go to the simulator. This is a long lab. Okay, so tools, run simulation tool. Now there's, I don't know, possibly hundreds of ways you could mess this up along the way. And I'm not there in a classroom with you to go over to you and fix every problem, all right? So I need to explain things in a lot of detail. Otherwise, I'm swamped with hundreds of emails. I got stuck here. I got stuck there. Because this is a very difficult lab to introduce at this point. Some other terms, they just did a 4-bit adder for Lab 3. In other terms, they just did a plain 4-bit adder. This term is harder. Okay, it's going to come up. Yeah, there it is. The M logo at the bottom. Click that. Okay, here's something interesting. Look under work. Is there a test bench there? Yeah, you know why? Because you did simulation settings to set it up. Okay, so is there a simulation running? No? So it's good. So we can do file, new, project. You need to name it. Lab3Pt2. PT2. Okay, here's the tricky part where you would screw up. When you add existing file, you have to add everything in this list, in this files list. It needs to know about all these. Okay, this is not in a standard library. There's no way you can know about it unless you add the file. Okay, same thing for adder 4. Okay, so you have to add all these. There's 1, 2, 3, 4 to add. Okay, last time you had only the simulation test bench and one top level file, but now you have top level, 2 support files, and a test bench. Okay, so add. See what we find. Oh, under model sim, there's your test bench. Give it that. Go back in. What do you got? Go up a level. See where I'm pointing? Up a level. Up a level. Now, all these. Hold down Control key on the keyboard. All those. Could do it one at a time if you had to. Okay. Now, are you all there? Yeah. Got the test bench, the top level, the 2 supporting files. They're there. So compile. Compile all. Now, in this message window down here, look for errors. There's 4 compiled, failed with 0 failed with no errors. Now, let's say there was something wrong with the test bench. You would double click. Okay, maybe you were missing a semicolon here or a semicolon here. You could fix that and you could save it with this save icon. See, in this top left corner. Okay, and then you could recompile everything. Okay, now you're ready for simulation. So go simulate. Start simulation. Now go in the work folder, expand the plus sign. The one with test is the test bench. And your resolution is NS, nanoseconds. Select the test bench in the work folder, expand it, and OK. You see that? OK. Now what? OK, so names come up in the objects box. Select one of the names, doesn't matter which. And then go add to wave. Signals in region. That means you select one, it gives you all. That's what signals in region means. Now, It labeled the waveforms with these, which is all we really wanted to do. We want to add these object names to the waveforms. And we got that done. Okay? So all I got to do now is well, what happened now? It undocked. So go Window. Whoa! It lost it. All right, my waveforms are lost from undocking them. Boy, I got a problem now. What I'll do is, no, I don't need to save there. Let me see what I gotta do. Window. It should show me the window. Okay, so it lost the waveforms window. Some kind of strange bug. Window. Don't got it. Okay, do it again. Simulate. End the simulation. Yeah. All right, so I don't know what happened. I'm going to do this over again. So File, New, Project. Lab 3Pt2. Overwrite it. Okay, add files. Go quicker this time. So give it under model sim. Okay, the VHT. Then go under, go up. Okay, then pick control this. Okay, open. Okay, now close. Go to compile. Compile all. It worked. Okay, then go start simulation. Go expand work folder. Test nanoseconds. Okay. Okay, then pick one of these. Add 2-wave signals in region. Oh, there it is. There it is. As soon as I undocked it, I lost it. All right, so there it is. Okay. So this is tricky. Now, go back here. Where's your test bench? Well, that's not, you can't, no. Find your test bench here. So you've got 1, 2, 3, 400. And 400. So I think it's 800. So go back here. Total time going to be 800. Nanoseconds. Then reset on the left here, icon on the left, and then run. Whoa. Okay, now go zoom full. Whoa, okay. Now notice half of them have m equals 0, and the other half have m equals 1. Now the overflow is screwy. So let me look at this. Oh, I hit the X instead of, last time I hit the X instead of the dock. Undock. Okay, so there's some kind of problem here. No, that's actually good. Okay, so no, I need to expand these. So let me see this. See what kind of problem I got. Okay, so I've got 0 plus 0. Now you see how vectors gives us these white lettered numbers here? 0 plus 0 is 0. Now, and then you see it gives it here. 5 plus 4 is 9. gives it there even. Okay, and this is m equals 0, it's an addition. Okay, so that worked. Now this one, under m it's an addition, 0. So this one got 0 plus 0. No, I didn't want to do so many zeros plus zeros. How come I got 0 plus 0 again? All right, something wrong there. Now I got 5 plus 4 is 9. Now where's it go m equals 1? Oh, and this overflow thing is not working. Overflow bit is not working. All right, overflow bit is not working. Now it should work because I got that schematic from a working project. So don't know why overflow bit is not working. Do not know why it's not doing a proper sequence. So I got some debugging to do. And I probably got to make an addendum to this video after I got it debugged. Okay, so you see how hard this is? Why is that happening? Well, let me see my test bench. Okay. All right, actually, this is a subtraction. Let me fix this. Yeah, subtractions. All right, so I got... Oh, I didn't change them here. That's why. Okay, so I got to change it to... This one got to become 5 plus 4. Okay, so these second two got to be fixed. So this becomes 7. 7 plus 101. 101. And then I have 8 plus 8. 8 plus 8. Okay. And then I can do this. You go copy, Control C, and then go. We're going to give me a new line or not? Yeah. Go Control V. Now, this is the same thing, only m equals 1. And then these are subtractions. Okay, and save it. Okay, now go back to here. Okay, now we got to redo the test bench. So find the window for this. Okay, so this is new. So we just can recompile everything. Okay, now go back to the waveforms here. Now go restart and run. Okay, now go to overflow. Overflow works, almost works. Overflow almost works. Okay, so 0 plus 0 is 0. Then you got 5 plus 4 is 9. Then you got, okay, is m equals 0 addition. Then you got 7 plus 5 is overflow of 1 and a 2, which is 12. Okay, and then you've got 8 and 8 is a 6 with overflow of 1. Okay, then it got m is 1, so you got 0 minus 0 is 0. Then you got 5 minus 4 is 1. Then you got 7 minus 5 is 2. Then you got 8 minus 8 is 0. 0. Okay, 0. So I got it now. Okay, so I guess I'm done. Okay, when it was back here, I was struggling whether to give you the help with this or not. And then I forgot to elaborate the copy and pasted A's and B's. All right, so I guess we're done. I got it, right? Okay.